Hello everyone, this is Understanding K. I'm Skylar Bleed, I'm going to be teaching you today. You may notice that at times I will make long pauses or avoid eye contact. I can't really help it, so I'm sorry about that. I know it's kind of a teaching thing. As an introduction to K, I'll show you some example code. This is an example K program. This is what's called natural sort. So you give it a list of strings, which are actually numbers, and it sorts them based on which number is actually the highest, not the first character, which is what it will normally do. I'm not going to explain what this means. It was just to give you a taste to show, firstly, the terseness of it. It's only a few characters long, and also to show you how symbolic it is, because K is written almost entirely in symbols, not in words or keywords like most programming languages are. K is a mixture of APL and Lisp. If you're familiar with those languages, they're pretty old. APL is an array language, or a language that's based around arrays, which is what K is as well. APL is originally meant to be written as a mathematical notation long before it was a programming language. And because of that, it was meant to be written on, stuff like this, stuff like whiteboards, chalkboards, paper, and that is kind of the reason for the terseness. Originally, APL uses Unicode characters, special funky little letters like, that. Who knows what that means? Well, APL programmers do. K just uses ASCII characters, not Unicode. But it still retains that ability to be, written on a whiteboard. I'll write all kinds of example code all over this whiteboard. I forgot a verb, so this is going to be inserted at the end here. There's a special verb that we are going to go over that's called gets. Gets is a colon, if you can see that. And it's how you do assignment in K. So if I wanted to do a statement like A gets 1, 2, 3, 4, and then I later reference A, referencing A will give me 1, 2, 3, 4. Yeah, that's about it. It's just you assign things to things. So let's get into some real code here, or how to write code. So firstly, K programs consist of nouns, verbs, and adverbs. Just like in English, and these kind of have somewhat intuitive meanings, but we'll go over what they mean. So let's start with your first noun is going to be, a noun is a thing, so we're going to make a list, or an array or a vector. Those all kind of mean the same thing roughly. K is all about arrays, vectors, and lists. It's an array language, that's what it's all about. So there are two ways to write a list. We'll start like this. So that's a parenthesis, and those are semicolons. So this is a list of 1, 2, and 3. You'll notice that that's kind of obnoxious to write and looks kind of ugly. So there's another way to write lists, which is called strand notation, and that's just with spaces in between each item. So white space is significant in K. Now let's go over some verbs. So some of the verbs are things you do to nouns. So a basic thing would be, addition, so that's plus. Subtraction is minus, obviously. Multiplication is a star. That's kind of intuitive. The one that's not very intuitive is division, which is a percentage sign. And that is because slash is used in another way, which we'll go over later. So when you're using verbs, you can do simple stuff. You can do 1 plus 1, you know, that's easy. You know, 1 plus 1 times 3, that'll give you 6. But will it give you 6? That was a terrible transition, but what I was trying to say with that is the order of operations in K is actually all right to left. So this would be 3 times 1, which is 3, plus 1, which is 4. I said it wrong. Yeah, whatever. But I need to bring that up anyway. Yeah, so that's how the order of operations works. In K, it's all right to left, which will make more sense as you keep writing it. It's just so you can kind of strand together a lot of functions without having to add things in between. So there are some verbs which are called atomic verbs, and that you can write. You can do an operation and it'll do it on each part of the list. So if I do 1 plus 1, 2, 3, this will actually return a list which will be 2, 3, 4. So the 1 gets added to each item. There are some that aren't atomic. An example is, you know, a nice hash symbol. That stands for length. So it'll just return, if you do length on 1, 2, 3, it'll return 3, not do the length of each item. If you want to do that, there's a way we can do that, and I'm going to explain that later. I'm not going to go over every verb in the K language. There are a fair amount of them, and you can easily find that information by just doing a command in your REPL, which is \+. That will show you a list with all of the different verbs and what types they take and different overloads and everything like that. The next one that we're going to talk about is adverbs. And since it looks like I'm getting close to the bottom of the screen, we'll actually erase this. So, adverbs. There are 3 main adverbs that I'm going to go over. The first one that we'll talk about is each. So each is an apostrophe. What it does is it applies a verb or a lambda, which we'll go over later, on each item of the list. So you could do, for example, you could do tilde, each, 1, 0, 1, 0. This little guy right here means not. So it'll return the opposite value. And so this statement will return 0, 1, 0, 1, because it applies not to each one of those. You don't actually have to use each in this scenario because not is atomic. So these are equivalent. I just wanted to show you as an example. Another example that we could do is we could take a list like this, actually a matrix. Sure, like that. This is a matrix. You can see I put it on multiple lines, so I omitted a semicolon, but this is a matrix which has a list of 1, 2, and a list of 3, 4, 5. We can do length each onto that list. Should have written that up there. Onto this list, and that will return 2, 3, because this is 2, and this is 3. All right. The next adverb we're going to be talking about is over, or filter if you're from APL. Over takes, let me explain it. with an example. We'll do plus over 1, 2, 3, 4, 5. What this is going to do is this is going to take these first two items. It'll add them together because we passed it a plus. So it's going to go 1 plus 2. Then it's going to take this value, which is 3, and it's going to add that to the next one. So this is going to be 6. And it's going to then add that to the next one. So that's going to be 10. And it's going to add that to the next one, which will be 15. So in the end, this will return 15. There's one more adverb, which is similar to over. It's a backslash, it's called scan. It does the same thing if we do plus scan 1, 2, 3, 4, 5. You know, it adds them, so we get 3, we get 6, we get 10, we get 15. But then it's actually going to return every intermediate value that we've written here as a list. So it'll return us a list of 3, 6, 10, 15. You generally are going to see over more than you'll see scan, but it has its occasional uses. All right, so now you know nouns, verbs, and adverbs. So, you know, remember, nouns are things, verbs do things to things, and then adverbs modify verbs. The last thing that we're going to go over are lambdas. Lambdas are how you're going to reuse code and kind of compartmentalize code. So lambdas are just like functions in other languages, or methods, kind of, if you come from object-oriented languages. You write them with curly braces. So if you remember that bit of code I showed you at the beginning, that was a lambda. So let's start with x plus 1. That's kind of a very basic lambda to get started with. So by default, the first argument is named x to a lambda. The second argument is called y. The third argument is called z. So this is a one argument function, or lambda, making it monadic, mono for one. If it used 2, it'd be dyadic. And I assume if it was 3, it'd be triadic, although I don't actually know if that's true. The way that you call lambdas is you're going to use a bracket and separate the arguments with semicolons. So let's make this, instead of x plus 1, let's make this x plus y. So this will effectively make it just work the same as the plus verb. So if we pass it 2 and 3, like that, this statement will return 5. You can also assign lambdas to a variable. So if I want to say a gets this lambda, let's do x plus y times z, just to show you. Then we can call a 1, 2, 3. And this will return, if I quickly do some math, 3 times 2, which is 6, plus 1, which is 7. So this will return 7, I'm pretty sure. I'm not that good at math, though. Lastly, there's a notation that you can use if you want to change the names of the arguments or add more arguments. You just add a little bracket here, and you could say something like a and then do a plus 1. Just like that. And that's it. That's that for this section of K. You know, there's more to learn about K. There's loop constructs and if statements and other things like that. I might get into it another time. But for now, you should be able to complete a fair amount of problems using your own research. You understand the basics, hopefully, if I did my job. And yeah, have fun writing K.